हेलो एवरीवन। आज पढ़ते हैं और टुडे वी विल रीड फ्रंट एंड सिस्टम डिज़ाइन चैट एप्लीकेशन. ओके, सो इट इज़ रिटन बाय टाइगर अब्रोडी and it was written quite recently. So it's a 9-minute read, and so let's read it out. So what is the table of content? It has an introduction, it has a clarification of requirement, a high level architecture, a data model, an API design, an optimization and edge cases, taking it to production. So let's go ahead and see. We are gonna do a front end chat system design exercise today. Okay, so the goal is to go through the entire process of designing this and think about all the trade-off and consideration. Now let's come to requirements. So requirement has one is like the component structure. So we have to sketch out the main component of a front-end architecture for a real-time chat application, identify the key components and their relationships. State management. So we have to discuss how you would handle state management within the front-end application, what data needs to be stored and managed. Real-time updates. Explain how you would achieve real-time updates in the chat interface. I know it should be with WebSocket, but yeah. What technologies or techniques would you use for real-time communication between users? Then user authentication. Describe how you would handle user authentication on the front end to ensure secure access to the chat. Then we'll come to UI UX consideration, discuss any user interface and user experience consideration such as message rendering, chat history, and responsive design. Taking it to production, in the end, we'll discuss how we could take this to production. Points to keep in mind. So you want to be thorough, but keep it at a high level. This means focus on what matters. This is also what shows seniority in front-end system design interviews. Clarifying the requirements. One is a functional requirement. Some immediate questions you might start with to clarify functional requirements. That is, what platforms need to be supported. That means either it's a web, mobile, or desktop, and just focus on the web for now. That can your answer can be answer like just mobile, which is mostly not sure. And then you can also check, is this for one-on-one chats, group chats, or both? And we can stick to one-on-one chat. Suppose that's your answer. Do we need to support file attachments or just text messages? Just text is okay is your answer. And some more that shows thoughts to the user experience. That do you want to show typing indicators? Do you want to show messages status like read, delivered, sent? After this, we'll come to non-functional requirements. Non-functional requirements are the things like performance, scalability, security, etc. etc. And when you think about chat system, there are several important things to consider. One is security. Messages should be encrypted, performance, latency should be low, back and forth chatting should feel like good and be fast. Reliability, if you send a message and go offline, it should not get lost. Okay. So this will be a high level architecture where you will have a client interface, you will have a chat list API, or not a chat list component, an outlet component, and a chat interface. And how you can do a chat API is like with ID, and this is the outlet. We have a selected chat like header, messages, and messages from. These three components will be here. Now this is in-memory store and this is the offline store. Now we have a WebSocket API which can talk to the server about it. So point about our high level architecture, we need both REST and WebSocket for this. For sockets, we need to handle reconnection, offline store to not lose message, in-memory store for what needed currently. For authentication, we will use JWT token. We have a refresh and an access token. Refresh is long-lived, access is short-lived. This needs to be secured, so the communication between two people should be encrypted. We will use Signal protocol to handle this for us. To be clear, we'd use a library to handle this. We also need to encrypt messages when storing them in the offline store. Okay. Now data model, how the data model should look like. So if you ever use WhatsApp or any other chat, think about your experience there. Someone seeing when someone is online, offline, seeing when someone is typing, seeing messages you have read yet, you haven't read yet, or you have not yet read yet. Seeing the status of messages like you get check marks, in Signal you get gray. Gray means send, double gray, and the blue one, all those things. Now let's talk about a list of conversation that is interface a user. That means it's a ID, name, image, status, last seen, where you can have a conditional operation on image and last seen. Conversation, we will have an ID, participants, last message, and last message at. Again, the same thing. Then the user conversation state will be there. It will be the state of each user's conversation. And it will have an ID, a user ID, an unread count, a last read message ID, an is typing ID, and a last typing at ID. Then we will have the main thing, which is ID, a client ID string, a conversation ID for the message, a content of the message, CNET of the message, sender, which user has sent it, sorry, status like sending, sent, delivered, read, failed. You might have seen failed also coming in some points. So yeah, and then we come to offline message. So you will have a sync status like pending, synced, or sync failed. Attempts like you will have a hard coded or whatever API through API number of attempts to do. Last attempt will be the date. Some interesting points here. User as a status offline or online. Last seen helps us to communicate when they were last online. We have a user conversation state. This is different conversation. Yeah, this is different per user. They are in the same conversation, but this doesn't mean everyone has read the same message. Each typing tells us when whether the user is typing. Last typing at tells us like what is the last typing state after a top. Like you can say that clear the typing state after a timeout. 100 count, we can see number of 100 messages, which is very good. Message has a state. Depending on the state, we show different indicators. Offline message is the message in our offline store. When sending, it be in pending. When sent, it be in synced. Now, what is client ID? It is used for idempotency and deduplications. We don't want to add the same message twice. So we check both server and client to see if a message is already in the store. Now let's talk about API design. We will have a REST API called Chat API. It can give us a GET call with the GET conversation. It can give us a GET call on the messages on the same conversation, which will have a conversation ID, cursor, limit, and all. And it will have a send message API, which is a post call. And we can do edit also like with a put, but let's forget about it. We have a cursor for get messages to paginate through messages. It wouldn't be efficient to fetch all the messages at once. Think of a message with a long history, right? You could also use pagination for get conversation, depend on the scale of the app, I guess. And then, but something to consider, sometimes conversation like isn't too heavy. Fetching all the conversation and then virtualizing should be a cool for most people. Now let's talk about WebSocket API is the bridge, right, to real-time communication. So we use REST for initial request or get older messages, but sockets is like what's happening in the real time. So we can have an interface called WebSocket events, which can have message.new, message.status, user typing, user online. Similarly, emits we can say when we send, message received, message read, and user typing. So message.new means new message received. It's a update in memory store and send message that it received via message.received. Now what is message.status? It's the status of a message that has changed. Here, one caveat is that we need to keep track of the order of the status. If a message is in red state, we get a delivered status. We shouldn't update the status because delivered is earlier in the chain. So this would be wrong when you think about the ordering, right? User.typing is we can know. Now let's talk about optimization and edge cases. Idempotency, we need to show that we cannot avoid this duplication and all those things. We should understand that one message should go once. Okay, too much thing will unnecessarily make your problem. Client side storage, we go for IndexedDB for offline storage. The nicest thing about IndexedDB is that it can store large objects and also sync across tabs. So you can imagine user open multiple tabs and you want to sync the message across the tabs. This is possible. Network. The user's network is unreliable or not reliable. If they're offline, you should tell them that. And if we need to send messages that are offline, we should queue them up and try to send them again when they are coming back online. It's important here how we send them. The ordering matters. A solution here would be to send them in a batch per conversation and let the server handle the ordering based on the client side timestamps. Now, the client side timestamp may initially be used for ordering a message by the sender, but then it gets updated by a server to a proper timestamp. If you have Discord for a while, you know that messages when you are offline to get sent and can be out of order. It's a trade-off. Other thing which was forget, like when you we are gonna need some sort of sync manager to deal with this. It should deal with queuing up those batches, a batch per conversation. For the queue, we can use something simple as an array. The sync manager can think of its own class. This doesn't need to do with anything fancy, but to be fair, it's be good. I don't know what he's trying to say. If I include it in the architecture for clarity. Once again, we can check navigator.online, get all the messages with status pending from IndexedDB, group by the conversation ID and send in batches. Okay. Performance, lazy loading, code that's not needed. Okay, good. Use virtualization for chat messages. As the user scroll up, we might end up with a lot of messages in the DOM. Prefetch the next messages when the user starts to scroll. This way, it doesn't feel like they need to wait for the batch of message. Taking it to production, you need to behind a feature flag, gradually roll it out to the user. This means not letting everyone use it at once, but a subset of user. This way you can get feedback and showing it's working with expected, with measured things going wrong. In the case of building a full product, you want to do it incrementally per feature. You wouldn't have to and like do the entire product behind a big feature flag. Testing, make sure it's work expected, and error tracing or tracking. We need to know when things go wrong. We should track the errors that are happening in the production. Sentry is an amazing for this. We can also see the entire stack trace and what's happening with Sentry to understand this. Performance monitoring, we should have that, like message metrics. What is the send latency in millisecond? What is the delivery latency in millisecond? What is the WebSocket connection time, reconnection count, get messages latency in millisecond, conversation latency in milliseconds. User behavior tracking, we're gonna do analytics to understand user behavior, and we can use tools like PostHog. Behaviors we might want to track is user event, conversation open, message is scrolled. Nice. So let's just complete this. I think it's a good blog. So I do will get a follow. I'll do give this blog a follow in some time. But I read it out and I feel like it's a good one. And for today, this is it. And we'll see you in the next video. So for now, that's it. Have a nice day. Bye bye.